Good evening, class. Tonight we are going to take a look at our Chapter 4, um, Chapter 4 class, which is going to go over more object concepts. So this is going to be utilizing methods and classes and things like that to generate or create objects within our code. We're also going to take a look at understanding what blocks and scope is when it comes to Java programming. We're going to overload a method and look what that looks like. We're going to talk about different ways to avoid ambiguity, which is just repeating the same amount of code or same logic multiple times within your program. We're going to use this reference, which is just a pointer type reference to point to an allocated memory within the software. We're going to use static fields. We're going to use automatically imported pre-written constants and methods, and then use composition and nest classes. Okay, so lots to cover in this video, and we're going to go ahead, jump right into it, and get through hopefully all of it rather quickly. I do want to put out next week will be a test covering chapters 1, 2, and 3. That was supposed to be this week, but I was having issues with Blackboard, so you lucked out on doing a test this week, so the test will be next week, and you'll have a week to cover it, and I'll post a video kind of discussing that as well. So let's go ahead and just get started. We're going to take a look at our code that we wrote last week. Continuing with it, but in this case, I'm going to get rid of everything in here because we don't need it. We don't need it for this example. Now, blocks are basically the use of opening and close curly braces, as you see here. Right here, that's a open curly brace. That is a closed curly brace. Now, blocks have two forms. You got your you got your outside block, and then you got your inside block. And what that means is this curly brace and this curly brace here on line 5 and 10 is the outer block, and then in here this curly brace here and this curly brace here is considered the inner block. So is a block of code within the public class. Okay, so it's just a way to structure your code. If we take a look at this example here, we got the public class main. This is the outer block. It starts with the opening brace here. So it's just an opening brace. And then with this method that we have here, this main method, we have those curly braces there, which is the inner block. Now, to give a example of this, we should be able to come here, do a give me 1 second. Let me undo that. Oops, too far. System.out. What am I doing wrong? Hang on. I am having so many issues right now with my keyboard, but we're going to use system.out.println. Not there. Having issues. Okay. So if we do a int a number, and we're going to set that to 10 right there. We're going to do a system.out.println, and we're going to print out in outer block, comma, a number is, and then we're going to do a plus a number. So we can see what that is. So that's going to be the a number. Now, I'm going to come in here, and then we're going to create. So right now, I'm having this curly bracket right there and this curly bracket act as the outer block. I'm going to insert a inner block of code, just using those curly braces again, lined up with the system, as you can see in my code. And then I'm going to do int a number equals 512. And then I'm going to do a system.out.println, and I'm going to do in inner block a number is, do a plus, and do a number, which is the variable, plus, oops, and another number is, oh, sorry, this is supposed to be another number in this example. That, so in the inner block, a number is that, and then we're going to add another number is, and this is going to be the inner block, variable plus another block, or sorry, another number. And I should be able to just input that just like that, so it's on one screen and you can see it. So right now we have this inner block of code where we created a new variable, set it to another block, and then we're referencing a number, which is the one in the outer block. Now what we can do, if I do another system, not print line, I cannot type this evening, in outer block, comma, and we're going to do, yep, a number is a number. All right, so we look at this right now. Oops. We have our outer block, which is this curly brace and this curly brace here. So those two. That's the outer block, and we defined a number as 10. We did a system that outprint in outer block a number is plus a number. Then we come in here to this inner block of code, and we got int another number 512 system that outprint in inner block a number is that, and another number is another number, which is going to be 512. And then we're going to come out of the another number where another number ceases to exist because it doesn't exist outside of these curly braces here. And we're going to run it, and we're going to see what the output is. So we can see in outer block a number is 10. Okay. And then another number, we have 512. And then in outer block, a number is 10 again. Now, what happens if I try to reference another number? Let's say if I want to try to reference that and I run it. We're going to get an issue. And that issue is the import Java util scan is... that's not the issue, sorry. Another number cannot be resolved to a variable because it does not exist. So this variable, when you're using blocks or using your curly brackets, the another number only exists within those curly braces. It does not exist anywhere else. So keep that in mind when you're using your blocks there. Now, scope is the portion of the program within which you can refer a variable. So it comes into scope, or it comes into memory when the variable is declared. So in this case right here on line 7, let me do that. This comes into existence. So that variable basically comes into existence here, okay? And then it can be used, it comes into scope, it can be used throughout the program. As you can see, I can reference this variable, the a number, within this block, okay? Because that's where it comes into existence. It goes out of scope when the variable ceases to exist. So if we talk about this, another number here, this variable only exists within these curly braces. So when the Java compiler reads these lines of code, as soon as it hits this line right here, the close curly brace for this inner block, another number at that point ceases to exist, which is why I couldn't reference it in this line. And so that's the definition of scope. You can... So when it comes to redeclaring the variables, you cannot declare the same variable name more than once within a block. So basically within this curly brace and this curly brace, I cannot redefine this same variable twice. Okay, it gives me an error message or the red squiggly line because that's not correct. I also cannot reference it here, right? Because it's already been referenced here. It's a global variable, if you will. So it's already referenced there, so I can't reference it again. Now, however, because this variable, the 512, ceases to exist once I hit this curly bracket right there where it's outside of that inner block, I can not redeclare it, but I could declare it in the outer block of code because I only declared it within the inner block of code. And I know that could be a little bit confusing going between like inner and outer blocks of code, but just remember, if you declare a variable either here where you can do int a number equals 10. If I declared it there, it's considered a global variable. Is it there or is it outside of there? Hang on. Nope, can't declare there. If I declare it here, it will be considered a global variable. If I declare it here, it is also considered a global variable to anything within this curly bracket and this curly bracket. So line 5 and line 17. So you can see here I can't redefine it. So that's something to consider when you're declaring your variables. If you have a variable that needs to be used throughout all your methods or everything that's within that section of code, declare it as a global variable here. That way you can use it within any portion of your code. Now you could do even a inner, I believe, line of code. So if I did an int another number equals 512. So I could do and this is what we call a nested block or a nested curly brackets, is where you declare, not declare, but have a inner block within an inner block. Again, could be a little bit confusing, but as we go through more examples, I'm sure it will start to make sense. So I'm going to go ahead and clear this out. But that is, that's the difference between blocks and scope. Now, another trick, not another trick, but another thing to keep in mind when we're coding is the difference between overriding and shadowing variables. So you can override a variable with the override, not method, but I'm going to call it a reserved word, but it's an override that allows you to override the variable's previous value. So this occurs when you use the variable's name within the method in which it's declared. The variable then takes precedence over any other variable with the same name in another method. So what that looks like here is when I have the a number declared here, whenever a number is used in this main function, it retains the value of 10. So it will always be the value of 10 throughout this program. Now, when I create a new method, go here. Let me go ahead and just, do I want to clear that out? Now I'm going to leave this here. That's system, a number, but I'm going to clear out the rest of this here. And what I'm going to do is I'm going to declare a method within here, and I'm going to do a, not here, but outside of the main function. I'm going to do just a public static void first method. So we're going to create our first method here. We're not going to return a value, so we don't need to have a return statement. I'm going to do int a number equals 77. To have that colon, and then we're going to do a system.out.println line, and we're going to do in first method, parentheses, at first a number is a number. Okay, so in first method, at first a number is a number. This a number that I have defined here resides at different memory addresses than the a number up here. So line 6, when I declared that variable, that a number exists at a different memory location within your computer than this a number. So it's declared separately since we're looking at two different types of methods. Okay, so this a number only exists within this main function or method, and then this a number here only exists within this method. Now I can declare another method. So if I do another public static, and in this void, and we're going to do second method, but this time we're going to pass it a value, so a number. We're going to do a system.out.println, and we're going to say in second method at first a number is plus a number, and then I will come here and I'll do a number equals 862, and I need my semicolon there, and then I'm going to do a repeat of this line there, and it's going to be system, so in second method after assignment, a number is a number. So I'm basically going to repurpose this. So a number also resides at a different memory. So this a number here, so this is just 3 different ways to actually declare a number. Each time we declare it, we have a number here at one memory address. This a memory here is at another memory address. And then this a number here is at a third different memory address. So keep that in mind. Let's go ahead and call these functions just to see what comes out. And if we run this, we can see in outer block a number is 10. So in here we have 10. In first method, at first a number is 77, which we see here. In second method, at first a number is 55, which is what we defined here. In second method, after an assignment, a number is 862. Okay, so we were able to redefine this, and then I should be able to, if I do a plus, do a hang on, I gotta have those. Oh, I gotta have a okay. Bye. Okay, apparently I cannot reference the main function, so that's okay. So I'm going to just back out of that and just leave it at that. And we'll continue. But that's 3 different ways where you could declare the same variable. It's just located at different memories within your computer. Now let's talk about overloading a method. So you overload a method using one term to indicate diverse meanings. This can also be done by writing multiple methods with the same name but with different arguments. So if I did, we have second method here, and then second method here. It should give me an overload. It does not. Interesting. Okay. But overloading a method is writing multiple methods with the same name but with different arguments. Well, did I spell those right? Method. Oh, that's right. Why? I spelled them different. Method. There we go. Oops. Okay, so it's basically writing second method and the second method with another argument. The compiler, so the Java compiler, understands the meaning based on the arguments used within the method call. It is convenient for programmers to use one reusable name for tasks that are functionally identical except for argument types. Now, you don't... So yes, that is possible if we have... I'm just testing something real quick. Yeah, that works too. So I don't know. But that's a way to overload it. Now you want to avoid overloading your methods as much as possible. When we're talking about methods, there is a way that you can automatically type promotion in method calls. So in certain applications, it contains just one version of a method. You call that method using a parameter of the correct data type or one that can be promoted to the correct data type. So what that means is if I have int here, int a number or int another number, I should be able to do 55.6. Nope, it's going to return an error because it cannot do that. It doesn't make sense though. Sorry, I'm trying to understand the example that I've provided for this one. So when it comes to the promotion of data types within the method, it's best if there's a possibility that you're gonna be sending a decimal value or a float. It's best that you have these numbers as double, so that any value can go into this field. So 55 can go into that first argument, or I could do 55.5. And it will still go into that A number argument. So you can see that it's 55.5. There is an order of promotion where double is the highest data type, and then it goes double, float, long, and then integer. Integer being the lowest one. So when you're dealing with numeric values, it's best to use double so that decimal points can be used if needed instead of going back and rewriting your code. Now, when we're talking about ambiguous situations is basically when the compiler cannot determine which method to use. So if I had two methods here, I'm going to declare this as int so that it looks right. Now I'm going to clear out this. Basically, what I'm creating here is a ambiguous situation where the compiler is not going to know when I run this which method to use. Am I going to use this second method, or am I going to use this second method? And then I'll get error message where it says duplicate method, second method. So that's an example of an ambiguous situation. Overloaded methods correctly provided. Overload methods correctly provide different parameter lists for methods with the same name. So if I have double a number here, int another number, actually I'm going to move that another number. Oops. I'm going to move that one here. You can see that it already overloaded this method. Is saying the method second method int, and the type main is not applicable with the arguments. Let me throw in an argument. 55, and then this one says this method. Oh, I have to get rid of 66. Let's do 66 there. And that's a way to just overload methods. It will still run, but it's considered overloading your methods because you have two methods with the same. If I put int here, there we go, it's showing duplicate method, second method, int, and type main. So it's the same one essentially. Illegal methods, or methods with identical names that have identical arguments listed but different return types. So if I had int here, int there, return a number. Oh, another number. Duplicate local variable, another number. What? Y'all could probably just fast forward through this little break. I'm confused on why it won't let me return duplicate local variable a number, but it's not. Oh, is it because it returns a number when I call that method there? Gotcha. Let me do a number 1, 1, oops, 1, and 1. It still won't let me. So after looking at the issue and everything, I spelled return wrong. And that's why it's not working. So, yeah, that's always great to figure that out. So I could return a number. Oh, it's already declared, so let me get rid of that. So I can set a number to 55, return a number, and it will return this, but we have an issue because it says the method second method int, and the type main is not applicable with the arguments. Basically, even if I have 55 here, it ain't gonna work sending a number here because there's two methods even though the variable is different. And here, it's going to continue to fail because there's two methods with the same name, and you can't do that. So I'm going to get rid of that, get rid of that 55. I'm going to define this int a number, which is going to return 55 to this second method here. Oh, sorry. Static. There. And that issue is resolved, but it looks like I need a return statement here. Spell it right this time. And then return a number. So that's just an example of an ambiguous statement or overloading your methods, which you don't want to do. Also make sure that you spell return correctly, because that's an issue as well. Now let's talk about constructs. Constructs are creating and calling constructs. So Java automatically provides a construct method when class created default constructors do not require parameters. Basically, if a class doesn't require any parameters to be used, it automatically creates that constructor. Now you can write your own constructor methods, which will ensure that fields within classes are initialized to their appropriate default values, and then constructors can receive parameters used for initializing processes within that class. When you write a constructor for a class, you no longer receive an automatic or you receive the automatically provided default constructor. So once you create one, you can't use the default one. If a class only constructor requires an argument, you must provide that argument for every object the class is created. If you don't, your object won't work. You can overload these constructors pretty easily. So if you use any constructor parameter to initialize values, or for any other purpose, you can overload that constructor. As well as if a constructor parameter list differs, there is no ambiguity about which constructor method can be called. So you want to make sure that the list or that any arguments used for the constructor are the same. So if we go to the employee class that we've already created, we have a few things already created in here. We have a private int imp num, and then we have a employee int num. Do we not? Nope, don't have that. So let's type that in real quick. We're going to do a private. Nope, we're going to do employee int num, and this is going to be considered a constructor. So that's one constructor. And that's going to be the second constructor there. So this employee class now has two constructors. Just like that. So when you're initializing an object from a class, the memory is reserved for each instance field, or so like all of these variables here are considered fields. The memory location on your computer is allocated and reserved for that class. It is not necessary to store a separate copy of each variable and method for each call for each instantation or initialization of the class. In Java, one copy of each method in a class is stored. All instantiated or initialized objects can use one copy of those methods. So we need them. So it doesn't. What I mean by that is all these methods here. So if I create multiple employees, those employees become objects. So all of these methods here are reserved once and are used by all the other objects. So it doesn't allocate all those methods per object you create. For references, a reference in Java is an object memory's address. That's where this information, so all of these private fields or private variables, is stored. Implicit means to automatically understood without actually being written. So that's where this reference or this dot, and we'll get into an example here shortly, comes into play. So this reference is a reference to that object and is passed to any object's non-static class method. So that's going to be all these methods because none of them are static. This is also considered a reserved word within Java, so you can't use it as a standalone variable name or a method name or a class name. You do not need to use this reference and methods you write in most situations. Okay, so an example of this public, where's my... So if we look at this method right here, this public int get emp num, which is get number. This reference, once we get to it, is sent into this non-static method right here as a parameter automatically. You do not and cannot reference or write code for it. You do not need to use this with emp num. However, when we get to however, you can explicitly use this reference. So if I wanted to return this .emp num reference with emp num, the two methods in this figure operate identically. So basically, this get num with this right here, or just get emp num or return emp num, will behave identically. So you don't need to, you can reference this right there if you wanted to, but you don't need to. This reference implicitly received by instance methods, which we'll take a look at, used to make classes work correctly when you're referencing like objects once they're created. And then when used with a field name in a class method, the reference is to the class field. So these class fields here, well, not those ones because those are private, so you can't reference them, but any other values, so like this one, emp num equals 999, you can reference that. When used with a field name in a class method, the reference is to the class field instead of the local variable declared within the method. So when we're using this reference, we need them to make overloaded constructors more efficient. So this helps us avoid repetition with constructors. And then constructor calls other constructors using this. More efficient and less error prone when you're using this this form. So we're going to create a new class over here. So let me save this. Let me save you. We're going to create a new class, and we're going to call this class the student class. So student.java. So we got a new class. We're going to create two variables. We're going to do private int student num, and then private double GPA, just like that. And then we're going to do student. So we're going to create our first constructor here. So we're going to do student int num, comma, double, and average. And then we're going to do curly braces so that we can write stu num equals num, and then GPA equals average. Bam. And that's our constructor. That's gonna, anytime we initialize the student class here in the main, it's gonna require these two parameters and then create that object without us having to do a constructor. And the constructor is like the, if I come in here, move that down. So a constructor basically is when you just identify, so if I had employee new emp equals new employee. Okay, so that's this right here. This line of code right here, line 6, that's considered a constructor because I'm initializing this. By adding, and let me get my code back clean again so it doesn't look bad. By adding in the employee class this information here, I no longer need that statement. And the same with the student. I no longer need to do student equals new student or new student, however you want to call it, because I initialized it. So I should be able to just call student and put in the variables in order to create that object for me. We need to add the student GPA. So we're going to do student double average. And then we're going to come in here and we're going to do stu num equals 999. And then GPA equals average. Just like that. The next method we're going to do student. We're going to do int num again. Come down here, we're going to do stu num equals 999, and then GPA equals 0.0. And then we're going to do student. Lastly, we're going to do student stu num equals 999, and then GPA equals 0.0. And those are all the constructors that we're going to need to define for this particular class. So each constructor contain similar statements, as you can see here. And I'm going to get rid of these extra spaces, white spaces, just to kind of keep my code all nice and pretty, like just like that. Going to save that. That way we can reference this class in our main class. So we stay in the student one. If we take a look, each of these calls to make basically all of these constructors or overloaded constructors, which these are considered, we can add this class, this dot reference into this code to make it more efficient. Each of these calls to this with the parentheses calls the two parameter version of the constructor. So if I have int num and double average here, part of this, then what I can do, like so in this student double, I can add in this and then put in 999 comma average, and it will reference this constructor after it's been created. And I could do that for each one of these lines here. So instead of this one, I can do this and then num comma 0.0, and then in this one I can do this, and it would just reference this object. And then I need to make sure I have that there. So that's just another way to use this reference and to make the this class work more effectively is by using this instead of having each constructor, because that just overloads the class and those constructors. So you want to use this when you're referencing these values. Now, in terms of the static fields within classes or class methods do not have this reference. So if you have a static method, you don't use that. Have no objects associated with them. So anything that is static is not associated with an object. Class variables, however, share by every instantiation of that class. So anything that I have public or any variable that is defined within this class that I use to store information is accessible by that class or by that object. Only one copy of a static class variable per class. When we're using constant fields, we create name constants using the word final, and I talked about this before, so I can make this one a final. Well, not that one. Let me go back to main. When I'm looking at this int a number, I can make this a final int number, a number, so basically I can't reassign it. If I try to reassign it here, You can see that it gets that red curly brace and basically says the final local variable cannot be assigned. Basically, that number is final and I cannot change it. So no matter what I use that variable for here, I cannot change that value from 10. It will always be 10 if you have final in front of it. So if we go back to the student class here, save that again. We're going to do a private school ID because it's never going to change. We're going to do private final because it's never going to change. Sorry, static final int. I'm going to do school underscore ID equals 1, 2, 3, 4, 5. That's going to be the school ID. And then, of course, I still have the student num and then the GPA here. So if I try to change the school ID, I will always get a message because you can't change it. Okay? In this, we're going to go ahead and change this first constructor. We're going to make it a public. And do public student int num double, int. And change this value to stu num. And then this one's going to be GPA. And then we're going to set this here to this dot stu num equals stu, which is student number. And then again, we're going to do this dot GPA equals GPA. And this is going to be our new constructor that we have for this. We're going to create a new method for public void. Public void show student. And we're going to do a system.out.println. And we're going to do student hashtag, which is going to be the number, plus stu num, plus GPA is plus GPA. And that's going to let us know what the student's GPA is after this is created here. We can do an example. So if I call it here, I'm going to get rid of this main method right there. We should be able to call the student. And then do, if it's student num, we're going to do 1, 2, 3, 4. And then we're going to do his GPA, which is going to be 4.5. For main student 1 equals new student 2, 3, 4, comma 4.5. Okay, and then if I do a student 1 dot show student and then run this, this should student number 1, 2, 3, 4, GPA is 4.5. So this created the object here without having to like create a constructor here to store that information. I just added the information right there. So you can see that student, so we have public student, we added the student name, GPA, created this object. We can see that student 1 show student is student number 1, 2, 3, 4, GPA is 4.5. So you can see that that field works. If I wanted to add a method to, we'll cover that here in a second. So using automatically imported pre-written and constants and methods, we're going to take a look at these rather quickly because we're coming up to the top of the hour on this video. Mini classes are commonly used by a wide variety of programmers, and so we use these things called packages and libraries to add more functionality to our code package or our overall program that we're trying to write and define. Package or libraries of classes is a folder that provides a convenient grouping of classes that you can utilize. Many contain classes available only if they are explicitly named within a program, so you have to import them like we have here in the main. This import java.util.scanner comes from a library of classes where scanner is a class in itself. Java.lang is a package. Java.util is a package. The .scanner is a class within the package that you can use. They only automatically imported named packages. So if there was that little light bulb that I showed before, I'm not calling any of those, so I can't show you. But you can automatically import it by clicking on this little light bulb and fix your imports or add an import if it didn't have it. Java.lang.math the .math part is the class. So like .scanner is a class, .jOptionPane is a class. You don't need to create an instance of it. It imports automatically, and you can use any method within that class. So in the PowerPoint that I'm going to have uploaded, there's different examples of what we can use within the .math class that you can use within your program. Using pre-written classes, you have to use the entire path with the class name. So basically java.util.scanner, that's the entire name, and imports that class and package so that you can use it. You have other ways where you can find classes, and that's with the wildcard symbol, which is an abstract where you can look for a particular name. To import that type of library. You can also use local date class to bring in the local information from your computer if you want to have that information used as well within your program. When we talk about composition and nested classes. So the composition describes the relationship between classes and when an object of one class data field is within another class. This is called a has a relationship because one class has an instance of another. So if I wanted to do, I'm going to test this out real quick. We have employee. So if I did, let's create another file real quick. We're going to call this school.java. So we're going to have this class school. We're going to create a few variables. We're going to do private. We're going to do name and address. Name add. We don't have that, so let's do private. Let's do student. Student 1. So that's going to create that student 1. We're going to do a private int enroll. Okay, so we haven't created the name add and address. But what we can do, not name add, we're going to do student because I created the student. So we're going to do student 1, which is what I called equals new student. And we're going to do 1, 2, 3, 4, and then 4.5 because that's the code there. So that's going to create student 1, should at least. And then that enrollment equals enrolled, which doesn't make sense because that's an integer, but give me 1 second. We got a few error message. Class body should be closed. This probably has an issue with this right here. So we got private int enrollment, private student, student 1, which is right. Public school, string name, comma, string add, colon, int zip, comma, int enrolled, then bracket, and then we have student 1 equals new student 1, and then enrollment equals enrolled. Got that. I'm going to do a public void display. And system.out.println the school show student. Oh, I guess I don't need that because I'm going to show the student that way too, so I don't need that. So let's fix some of these errors real quick that we have. Public school, let's see, syntax on token, comma, invalid block statement. Put that one. Private student, student 1. Okay. Private int enrollment, public school, string name, comma, string add, that. Yep, bet you that was a typo. Okay, so if I save this, public void. So this, I'm calling a class within a class to create this student 1 to be used in here. So student 1 does show students. So if I go back to main here, I'm going to get rid of you, and this time I'm going to call the school dot display. Oh, I gotta, sorry, school, new school equals new school. And I should be able to do new school dot display. But does my school have arguments? It does. So I need name, address, zip, and enrolled. So I'm going to call this Franklin Smith. Oop, wrong spot. Franklin Smith, comma. Address is somewhere. Is that a string? String. Yep, somewhere, because I don't know the address of the actual school. And then zip is going to be 64015. And then number of enrolled is going to be 5. So we filled all that out. That information is going to be school. I could come back here to school. We're going to do student 1 equals student 1 enrolled, but the displays student information, student 1 dot show student, which is going to give me that information. And then I'm going to do a system.out.println. I should be able to do this dot school. Or actually, I should be able to just do this dot name. Because it's there. Oh, I can't reference it there in this, so I can't actually do this. So let me do, should be able to do, so this creates that student enrolled. You know what, let's just see what this does real quick. Do F5, student number 1, 2, 3, 4. Am I calling that from something else? 1, 2, 3, 4 GPA is 4.5. Is that what I did here? Yep, create it 1, 2, 3, 4, 4.5. So you can see that I created one class, which is going to be the school. So Franklin Smith, new school.display. I could also do, if I wanted to, I could do print. Sorry, let's do system dot, because we're at an hour, system.out.println. And then do this dot name. Nope, won't let me do that, but I could do new school dot name. I guess I can't do that. Why? School. Void display. So this creates the school, but it only initializes that. I don't actually add that information to name. Yeah, I don't add that information to the school. Oh, I wonder if that's why. So let me do this. Let me do a private name and address here equal, or sorry, new add there. And if I come here, I should be able to do new add equals new name and address. Sorry, name and address. That's enough. New name and address. And then we're going to give it a name, comma, add, comma, zip. Which I really don't think this is going to work either, because I don't have that as a class. So that's not going to work either, and I'm not going to create the class right now because we are out of time on this video. So I'm going to go ahead and end it there, because what I mainly wanted to show you was just a nested class. Basically, we have this class here, which is the public school class. Sorry, we have public class here. And then this one initializes the school, so it creates the school when I call it in this main function here. And then I create the student one, or just a student, which I can pass information when I create the school if I wanted to this student, which goes to the student and creates that new student as an object. So that's just most different ways that we could do it. I will provide some code later this week to give you a more in-depth look at this. I know I was kind of like a little bit all over the place. I promise next week I will be a little bit more together when it comes to the coding and have a definite example. If you have any questions, feel free to reach out to me. Again, I'm going to post some code to Blackboard later this week, just showing the difference with classes. I'm going to create a school and how all that works. So look for that. If you have any questions, feel free to email me. And yeah, y'all have a good night.